So EKGs, for what it's worth, it's definitely worth your while to read up on EKGs, read up on axes, read up on what makes things tick. This is lead 2. This is lead 3. This is AVR. I'll just write R. This is AVL. This is AVF. And it's just important just to know, kind of what you're looking at and why things positively or negatively deflect. The general gist of things is that you have to look at the direction, and then you also have to look at the charge. So for example, if something is going towards a lead, that's a positive. If something is going away from a lead, it's obviously a negative. And if a positive charge is going towards a lead, then it's a positive. And if a negative charge is going towards a lead, then it's a negative. And what you end up doing, and what I end up doing, just to have a good idea of where things are going, is if you have a positive charge going towards something, it's just multiplication. Positive times a positive, it's a positive. So on your EKG in that lead, you will have a positive deflection. If you have a positive charge going away from something, it's a positive times a negative, which is a negative. So in that lead, you'll have a negative deflection. And of course, if you have a negative charge going away from something, that's a negative times a negative, that's a positive. And if you have a negative charge going, negative times a negative is a positive. And if you have a negative charge going towards something, then it's a negative times a positive, that's a negative. That's how to read EKGs real quick without going into much detail, but there you go. So what's next? What's next is atrial fibrillation, super common. The name of the game is that you have no discernible P waves. Why? Because that's atrial depolarization. That's what the P waves are. So if it's fibrillating, if it's not really contracting, then you won't really see any P waves. The second giveaway, it's irregularly irregular, meaning that your R to R interval, R to R, constantly keeps changing. Sometimes it's really hard to see if you got like a really rapid, rate. Like if your rate's like whatever, like 120. Sometimes it can be hard to see, but you won't see P waves. All right. So what do you have to watch out for in atrial fibrillation? Well, what you gotta do is you gotta watch out for thromboembolic events. You gotta watch out for strokes. All right. So what do you do with someone with AFib? Well, you really got a couple of options. You can do rate or rhythm control, and the choice of rate versus rhythm control is not a step 1 question. It's not a step 2 question. It's a step 3 question. And it's something you're going to do all the time as an intern and for the rest of your career. But so anticoagulation, rate or rhythm control, and then cardioversion. So there's a couple big trials talking about rate versus rhythm control. Let's not really go into that right now. The idea is that anticoagulation is really the big thing. So things like warfarin, things like the DOACs, the edoxabans, the apixabans, the rivaroxabans, and then the third option here, cardioversion. Cardioversion is really where you're in the cath lab and they just zap your heart to get it to convert your heart back into a regular rhythm. And when you're cardioverted, if you're an AFib and you're predisposed to strokes and stuff, If all of a sudden you get shocked into a normal rhythm, there's always the very real possibility that you've built up a clot, and now that you're pumping normally, that clot's just going to get pumped to your brain. So what you actually have to do, and this isn't a step 1 question, this is just like bonus info, you have to do an echocardiogram, specifically a Trans-Esophageal Echocardiogram, because you'll be able to see a part of the left atrium called the left atrial appendage, which is typically, it's like where 90% of these clots are in atrial fibrillation. And again, why Trans-Esophageal? Well, because the left atrium's, right there in the back, and it's just more easily viewed in that sense. So things that can cause AFib, hypertension is a huge one. Coronary artery disease is another big one. Sometimes you can have fibrosis of just the normal electrical tract. Sometimes things like, if you have pneumonia, or if you have some sort of massive MI or something from coronary artery disease. But enough about atrial fibrillation. Let's go into atrial flutter. Atrial flutter can be real fast. It's kind of similar, I guess, to atrial fibrillation. One of the big differences, of course, is that you have a normal R-to-R interval. Sometimes they'll tell you 4-to-1, 3-to-1, 2-to-1. It really depends on the amount of waves that you have. And then vfib. Vfib, if you can't identify a pattern, it's vfib. And with vfib, you defib. Look at that. Alright. And then AV blocks. 1st degree, 2nd degree, different types of 2nd degree, and 3rd degree. AV block just means there's a long time between the P and the QRS complex. There's a long PR interval. It's called an AV block because, well, the P wave is the atrial depolarization. The QRS is the ventricular depolarization, and so the AV block just means there's some sort of block between the atrium and the ventricles. So what you have to do is you literally have to whip out some calipers and just measure the distance between these things. All right. So 2nd degree AV blocks, type 1, type 2. Type 1, you can typically think of it as going, gone. Meaning you have a PR interval here, PR interval gets longer here, PR interval gets longer here, and then it drops the QRS interval, the QRS wave. Okay. Mobitz type 2 is you have a normal PR, you have a PR interval here that doesn't end up getting changed, and then all of a sudden you have a drop to beat. These cases, 9 times out of 10, they'll end up getting a pacemaker. You won't get a pacemaker for type 1. You will get a pacemaker for a type 2 2nd degree AV block, but not a type 1 2nd degree AV block. And then 3rd degree AV block, you'll get a pacemaker for this. And the big thing between here, the big difference between 3rd degree and 2nd degree AV block is that there's really no relation between the P waves and the QRS in 3rd degree AV block. And the big thing is that you will see it in Lyme disease. Sketchy micro has a cool thing about it. Even if you don't use sketchy micro, you should know this is super high yield. Yeah. There you go, folks. We went into some detail about how EKGs work and the direction of depolarization and your waves and stuff. And then just kind of normal EKG tracings.